Now, how do these equations change for when we have things being dropped? So the three equations of motion are delta x equals v final minus v initial divided by 2 delta t. All it is v average equals delta x over delta t. So I'm going to call this equation 0. So we're going to rewrite these here. So the first one is v equals v naught plus at. The second is delta x equals v naught t plus a half at squared. And the third one is 2a delta x equals v squared minus v naught. Actually, in general, people write it the other way around. So I'm going to write it as most textbooks will write it. 2a delta x. So v squared minus v naught squared equals 2a delta x. So how do these equations change when we go to ball drops? One big change is true, and a becomes g with a negative sign because it's pointing downwards. And the other thing you have to remember, final velocity at the top for your projectile is 0. Okay. However, your velocity is 0, but your acceleration is always 9.8. And the acceleration in the x direction is always 0. Remember those things for projectile motion. However, if your y acceleration becomes 0 at the top, what happens? It's like that Bugs Bunny cartoon, right? Right. So it just stays there. Like, or you know those cartoons in which they're have you seen those old Disney Looney Tunes one where they just fall off the cliff and they just hang there for a second and then they look down and they realize and then they start falling? Or has anyone seen that clip from Bugs Bunny in which they're falling, and just before they hit, they stop, like they literally break and stop. And then they say, what do you know, out of gas. Right? So if that was possible, that acceleration at the top would go to 0, think of Bugs Bunny, right? That's not possible. Then it will just hover there if there's no acceleration pulling it down. So just keep that funny thing. If you remember that funny clip in your head, I don't know how many of you have seen that, right? Where he looks back and then he realizes he's hovering in the air and then he starts to fall, right? Okay, are we back? Yes, we're back. So what will it be for the first one? V will be V0 minus GT. What will it be for this one? Delta y equals V naught yt minus a half GT squared. And the third one will be V squared minus V0 squared equals minus 2G delta y. And along the x-axis, what would they be? Along the x-axis, what do I know? Ax is going to be 0. So this will just be V equals V naught x. Delta x will be V0 xt. And this will be V0 equals 0 or V equals V0 x. So along the x direction, your velocity remains constant no matter which. Everybody understands that, right? We treat the velocities, we treat the motions separately and we do not mix them up, correct? So if you're talking about a motion like this, you always have V initial, and we always divide it into X and Y, right? So V0 has V0 X and V0 Y, which is V0 sine of theta and V0 cosine of theta. We all remember that, right? That's not something new I'm telling you. No, okay. And at the top, we know that VTY will be 0. However, VTX will be the same thing as V0X. Doesn't change. Acceleration in the x direction will always be 0, and acceleration in the y direction will always be g, and the value of g is always